Good morning, student. I am Dr. Dharmendra B N. This is my second session on Laplace transformation. Earlier class we discussed about some basic formula of Laplace transform. Here also I discuss about two Laplace transformation property and also some problems. Okay. Let us first discuss about what is first shifting property in Laplace transformation. If L of f of t is equal to f of s. We know that earlier class, if L of f of t, if Laplace of a function of t is equal to a function of s, then Laplace of e power plus or minus at into f of t. Earlier class we had discussed about there is only one term, Laplace of one term. Here we are to taking the two terms, e power exponential of plus or minus at into f of t is equal to, what is the terms is f of s minus or plus a. So we can observe the terms is if Laplace of f of t is equal to f of s, that means that then what we have to prove that here Laplace of exponential of plus or minus at into f of t. So here that addition of, when I have to compare this one, the addition of exponential term here. So that should be is equal to f of s minus or plus a. If it is a exponential is plus, the here the term is f of s minus a. Exponential is negative term, so this becomes that is equal to f of s plus a. So by using the definition, we have to prove this one, that first shifting property. Let f of t is equal to integral varies from 0 to infinity e power st f of t into dt. What we have to replace here? We should replace f of t by e power, only we can take in positive sign, that is e power at into f of t. Replace f of t by e power at into f of t. In the above equation, we get Laplace of e power at into f of t is equal to integral varies from 0 to infinity e power minus st. Instead of f of t, we should replace e power at into f of t into dt. Now, we can observe the terms is here the base is same. We can add that exponential power and also we can take minus as a common factor. So, therefore, that is equal to integral varies from 0 to infinity e power, we can take exponential as a minus common factor, that is s minus a into t into f of t into dt. Now, to put the term of e power minus st is equal to p. You can observe the term is put exponential of s minus a, instead of s minus a we can take that is as p. Therefore, it can be written as integral varies from 0 to infinity e power minus pt f of t into dt. So, when you have to integrate with respect to t, it should be appear is a function of p. Instead of that s in the earlier class we have discussed, it is a function of s, here that is a function of p. So, therefore, it can be written as f of p. What is p here? P is s minus a, because the term is Laplace of f of t is equal to integral varies from 0 to infinity e power minus st f t into dt. So, when I have to solve this one, when I have to integrate with respect to t, it should be appear as a function of s. Here, when I have to compare these two terms, instead of s here, that is p is there, that is f of p. So, now I have to replace Laplace of e power minus e power at into f of t is equal to f of s minus a. What you have to replace? Here we have to replace p by s. Similarly, one can show that Laplace of e power minus at into f of t is equal to f of s plus a. So, this is a very important formula. First shifting property, Laplace of f of t is equal to f of s then Laplace of e power plus or minus at into f of t is equal to f of s minus or plus a. If it is a positive sign, it will be appear in terms of negative. If it is a negative term, that function is positive, that is f of s plus a. Okay, we can take some example on first shifting property. Laplace of f of t in terms of f of s. First, to find what is Laplace of f of t in terms of f of s. Then we can replace s by, if it is positive term, we can replace s by s minus a. Suppose that exponential is negative, we can replace s by s plus a. Okay, we can concentrate on that term. So that is Laplace of e power at into f of t is equal to f of s minus a. Okay, first we can find what is Laplace of f of t. Okay, in terms of f of s, we can compare the term here. We can find out what is f of t. Except that exponential, we can find out what is f of t in the given problem. We can compare here. For the first problem, Laplace of e power at into t power n, that means that is Laplace of e power at into f of t. We can easily identify f of t is equal to t to the power of n. So what we have to find in Laplace of first shifting property, we can find what is Laplace of f of t in terms of f of s. After we can replace s by s minus a. Okay. So solution, first find what is Laplace of f of t. When I have to compare this one, f of t is clearly mentioned as t power n. So we know this Laplace of t power n is equal to n factorial divided by s to the power of n plus 1. Earlier class we had discussed about what is Laplace of t to the power of n, that is n factorial divided by s to the power of n plus 1 or gamma of n plus 1 divided by s to the power of n plus 1. So what we have to replace to compare the term is, after when I have to find out this is a function of s, we can replace s by s minus a because their power is positive. We can observe the term is, so therefore we can replace s by s minus a. It can be written as Laplace of e power at into t power n is equal to n factorial divided by, we have to replace here s minus a whole to the power of n plus 1. Similarly, can take in the second problem on first shifting property, Laplace of e power at into sin bt. Find that Laplace of e power at into sin bt. What is f of t here? So when I have to compare the with formula, that is f of t is sin bt. What we have to do it here? First we can find out what is Laplace of f of t in terms of function of s, that is we can find out what is f of s. Then after we can replace s by s minus a. Here also the exponential is positive, that is e power at. We can replace s by s minus m. Solution, we know that Laplace of sin bt is equal to, just we should recall what is the definition of Laplace of sin bt, that is b divided by s square plus b square. So this is a function of s, that is a parameter is here, s, b is a constant term. So what we have to replace here, s by s minus a. Therefore Laplace of e power at into sin bt is equal to b divided by s minus a whole square plus b square. And taking this some more example on first linear property, that is a first shifting property. We know that Laplace of e power at cos bt. We can easily identify f of t is here cos bt. What is the formula for cos bt in terms of f of s? That is s divided by s square plus b square. What we have to replace? We can replace s by s minus a. Therefore, Laplace of e power at into cos bt is equal to s minus a divided by s minus a whole square plus b square. Similarly, suppose we can change that negative sign. What is Laplace of e power minus at into sine hyperbolic bt? So, we can easily find out what the f of t is here, sine hyperbolic bt. So, first find what is Laplace of sine hyperbolic bt. So, we know the formula, sine Laplace of sine hyperbolic bt is b divided by s square minus b square. What we have to replace? So, we can observe terms of, so if it is a negative term, we can replace s by s plus a. So, the term we can replace s by s plus a. Therefore, Laplace of e power a t into sine hyperbolic bt is equal to b divided by s plus a whole square minus b square. Similarly, next one, you can find out what is Laplace of exponential minus negative sum, that is minus at into cos hyperbolic bt. So, we can clearly observe the terms as f of t is here cos hyperbolic bt. So, therefore, first find what is Laplace of cos hyperbolic bt, that is equal to s divided by s square minus b square. What we have to replace? If it is a negative term, we can replace s by s plus a. Therefore, Laplace of exponential of cos hyperbolic bt is equal to, can replace s by s plus a divided by s plus a whole square minus b square. Okay. Next property, that is a change of scale property. If Laplace of f of t is equal to f of s, then Laplace of f of a into t. So, in function that f of t, that we can replace f of a t, that is equal to 1 by a into f of s by a. This one is change of scale property. It will be very useful in inverse Laplace transformation. Okay. So, we can show this one, the solution by the definition. What is Laplace of f of t? That is equal to integral varies from 0 to infinity e power minus st f of t into dt. When I have to compare these two terms, we can replace f of t by f of a t. So, therefore, replace f of t by f of a t in the above equation. We get Laplace of f of a t is equal to integral varies from 0 to infinity e power minus st f of a t into dt. Okay. Here the formula, we compare the terms, is that addition term is here a is there, that is it can be written as, we can put a t is equal to u. So, therefore, put a t is equal to u. So, the integral can be written as integral from 0 to infinity e power minus s into u divided by a f of u into du by dA, because when I have to putting a t is equal to u. So, then that the value of t, the dt is equal to du by u, and the t can be written as u by a. So, here we have to should replace t by u by a, and also here that integral value is changing, the term is with respect to u, the terms is here also, that is a u, not t, that is a u. As u, if t is equal to 0, u is also 0. If t is infinity, u is also tends to infinity. So, therefore, 1 by a is a constant term, we can take it outside from the integral. Integral varies from 0 to infinity e power. So, when I have to choose that value, s by a is equal to some lambda f of u into du, because you can compare with the formula. So, that is why we can take in that value of s by a, that is equal to lambda, where lambda is equal to s by a. So, therefore, what is, when I have to compare the formula, this is a function of lambda. When I have to integrating with respect to u, it can be written as Laplace of f of u. So, therefore, or it can be written as 1 by a into f of lambda. What is lambda? Lambda is s by a. So, Laplace of f of a t is equal to 1 by a into f of s by a. Okay, we can take some problems based now. So, we should recall what is that Laplace transformation formula in earlier class. So, just we can recall the definition of the Laplace transformation. The first one is linear property. Laplace of a into f of t plus b into f of t. Can you remember? That is a into Laplace of f of t plus b into Laplace of g of t. Secondly, that is a Laplace of a constant function that can be written as a constant by s greater than 0, where a is a constant term. And the next one is Laplace of e power a t. Right, the term says that is 1 divided by s minus r plus a if s is greater than a. Next definition, Laplace of sin a t. Right, can you remember the formula is a divided by s square plus a square, s is greater than 0. Similarly, Laplace of cos a t, that is s divided by s square plus a square, s is greater than 0. Similarly, sin hyperbolic a t, that is a divided by s square minus a square. So, s is greater than the modulus of a. Similarly, cos hyperbolic a t, that is equal to s divided by s square minus a square. So, sorry, it's a mistake, the sign s square minus a square. And similarly, that Laplace of t to the power of n is equal to n factorial divided by s to the power of n plus 1, where n is a positive integer. And the next one, it is a first shifting property. Laplace of, today we have discussed this one, Laplace of f of t is equal to f of s. Then Laplace of e power plus or minus a t into f of t is equal to f of s minus r plus a. And lastly, we have discussed the terms is Laplace of f of t is equal to f of s, then Laplace of f of a t is equal to 1 divided by a into f of s by a. Using these formulas, we can discuss some problems on this class. Okay, first problem. What is Laplace of a plus b into t plus c into t square plus d into t cube? So, we can use the shifting formula. Sorry, you can use the linear property. So, it can be written as using linear property. What is linear property? Laplace of a into f of t plus b into g of t is equal to a into Laplace of f of t plus b into Laplace of g of t. So, therefore, I can consider that Laplace of the given function a into a plus b into t plus c into t square plus d into t cube, that is equal to Laplace of a by using the shifting formula, linear property, Laplace of a plus Laplace of bt plus Laplace of ct square plus Laplace of dt cube, where a is where the terms of the second term, third one and fourth one, it's a constant term. We can take it outside from the Laplace. Laplace of a plus b into Laplace of t plus c into Laplace of t square plus d into Laplace of t cube. So, therefore, the formula is Laplace of a constant term is a constant divided by s plus b into Laplace of t is, that is a t power n, that can be written as n factorial divided by s to the power of n plus 1, here n is equal to 1, that is 1 factorial divided by s square. Similarly, c into, here 2 is there, that is 2 factorial divided by s cube. Next term is t cube, that is d into 3 factorial divided by s to the power of 4, because the terms of Laplace of a is equal to is a divided by s, and Laplace of t to the power of n is equal to n factorial divided by s to the power of n plus 1. So, therefore, a by s plus b by s square, 1 factorial is 1, 2 factorial is 2, that is 2c divided by s cube, plus 3 factorial is 6 into d divided by s to the power of 4. So, when I have to take in that LCM, that is highest term is, that is s to the power of 4, it can be written as a into s cube plus b into s square plus 2 into c into s plus c 6 into d divided by s to the power of 4. So, this is the first problem. Similarly, second one, what is Laplace of exponential to the power of kt of a plus b into t plus c into t square plus d into t cube. This one is the first shifting property. So, Laplace of e to the power of at into f of t. Here f of t is this much, that is a plus b into t plus c into t square plus d into t cube. So, using linear property, it can be written as Laplace of a into f of t plus b into g of t is equal to a into Laplace of f of t plus b into Laplace of g of t. And the first shifting property, Laplace of e power at into t power n, the term can be written as n factorial, because the term is f of t is here, term is t to the power of m, that is n factorial by s to the power of n plus 1. You can replace a by the term is a is there, that is s by s minus a. Positive sign is there here, exponential. So, therefore, consider the given problem, Laplace of e power kt into a plus b into t plus c into t square plus d into t cube, that is equal to, using that linear property, the first term is Laplace of e power kt into a plus Laplace of e power kt into bt plus Laplace of e power kt into ct square plus Laplace of e power kt into d into t cube. So, here a is a constant term, take it outside. Here b is a constant term, we can take it outside from the Laplace. Similarly, here c, and here similarly d. Therefore, it can be written as a into Laplace of e power kt plus b into Laplace of e power kt into t. This is the term is, we can compare here, and plus c into Laplace of e power kt into t square plus d into Laplace of e power kt into t cube. That is equal to a into, what is that exponential of e power at, that is 1 divided by s minus k plus b into, when I have to compare with this formula, this one is 1 factorial divided by s minus k, instead of a, that is k is there, that is s minus k whole square plus c into, here 2 is there, that is 2 factorial divided by s minus k whole cube, and the term is d into 3 factorial divided by s minus k whole to the power of 4. So, that is equal to a divided by s minus k plus 1 factorial is 1 into b divided by s minus k square, here 2 factorial is 2 into c plus 2 into c divided by s minus k whole cube plus 3 factorial is, that is 6. 6 into d divided by s minus k whole to the power of 4. So, here we are taking that LCM. So, this is the answer. We have to simplify the term. Okay, next problem. If Laplace of f of t is equal to f of s, then Laplace of cos hyperbolic at into f of t is equal to 1 by 2 into f of s minus a plus f of s plus a. So we know that the term is here f of t. We can find out what is f of t. Laplace of f of t is f of s. And also we can observe terms if it is a cos hyperbolic at, we know the form of cos hyperbolic at in terms of exponential, that is 1 by 2 into e power at plus e power minus at divided, that is the term. So therefore you know that again the term of linear property. So therefore, and also Laplace of e power at into f of t, first shifting formula, that is f of s minus r plus a. Consider that Laplace of cos hyperbolic at into f of t is equal to Laplace of what is cos hyperbolic at in terms of exponential, that is 1 by 2 into e power at plus e power minus at into f of t. Okay. Here 1 by 2 is a constant term, we can take it outside, and also by using linear property it can be split into two parts, that is 1 by 2 into Laplace of e power at into f of t, we can multiply here, plus e power minus at into f of t, that is 1 by 2 times Laplace of e power at into f of t. We can apply the linear property plus Laplace of e power minus at into f of t. By using shifting formula, it can be written as Laplace of cos hyperbolic at into f of t is equal to 1 by 2 into, the first one is f of s minus a, because that positive sign is there. So therefore positive sign is there, it can be written as f of s minus a. If it is a negative term, the exponential, that is f of s plus a. The second term is negative term, that is plus f of s plus a. So therefore cos hyperbolic, Laplace of a cos hyperbolic at into f of t is equal to 1 by 2 times f of s minus a plus f of s plus a. So using that one, we can take some example. Laplace of cos hyperbolic 2t into t cube. So we can easily find out what is f of t. F of t is here t cube. So first we can find out what is Laplace of f of t. Okay, we know that the statement of Laplace of cos hyperbolic at into f of t is equal to 1 by 2 into f of s minus a plus f of s plus a. First we can find out f of t is t cube, that is Laplace of t cube in terms of f of s, it can be written as 3 factorial divided by s to the power of 4, that is f of that can be written as 6 divided by s to the power of 4, that is f of s. Now when I have to compare with the term of Laplace of cos hyperbolic 2t into t cube, here f of s is, that is 6 divided by s to the power of 4. What you have to replace, that is 1 by 2 into f of s minus a. Here a is here 2. You can observe terms of, the first term is s minus 2, the second term is s plus 2. So therefore Laplace, when I have to compare with these two formulas, it can be written as Laplace of cos hyperbolic 2t into t cube is equal to 1 by 2 times, what is f of s in the first term, we can replace s by s minus 2, that is 6 divided by s minus 2 whole to the power of 4 plus 6 divided by s plus 2 whole to the power of 4. That is equal to, here 6 as a common factor, or it can, when to multiply inside the terms of 2, it can be written as, that is 1 by s minus 2 whole to the power of 4 plus 1 divided by s plus 2 whole to the power of 4, or 3 times 1 by s minus 2 whole square plus 1 by s plus 4 s plus 2 whole to the power of 4. So the 6 by 2, that is 3. Similarly, the next one, if Laplace of f of t is equal to f of s, then Laplace of sin hyperbolic at into f of t is equal to 1 by 2 into f of s minus a minus f of s plus a. Here also we know the sin hyperbolic at in terms of exponential, that is 1 by 2 into e power at minus e power minus at. But using this similarly in terms of cos hyperbolic at here, sin hyperbolic at. We know that the linear property, if it is a negative term, Laplace of a into f of t minus b into g of t is equal to a into Laplace of f of t minus b into Laplace of g of t. And similarly, that the first shifting property, Laplace of e power plus or minus at into f of t is equal to f of s minus or plus a. Consider Laplace of sin hyperbolic at into f of t is equal to Laplace of 1 by 2 into, so the definition of sin hyperbolic at in terms of exponential, that is minus e power minus at into f of t. Therefore, here also 1 by 2 is a constant, take it outside from the Laplace, Laplace of e power at into f of t, here we have to multiply the terms of f of t minus e power minus at into f of t, or 1 by 2 times Laplace of e power at into f of t minus Laplace of e power minus at into f of t. That is, the term is Laplace of cos hyperbolic at into f of t is equal to 1 by 2 times. When I have to compare that first shifting property, if it is a positive sign, that is f of s minus a. If it is a negative term, that is f of s plus a. So therefore 1 by 2 times f of s minus a minus f of s plus a. So using this one, we can find out one problem. Example, Laplace of sin hyperbolic 2t into cos 3t. We know that Laplace of sin hyperbolic at into f of t is 1 by 2 times f of s minus a minus f of s plus a. So therefore, so compare the terms is here, f of t is cos 3t, sorry, cos 3t, not 2t, that is cos 3t. So therefore cos 3t is s divided by s square plus 9. Laplace of cos 3t is s divided by s square plus 3 square, that is 9. Okay, so that is equal to f of s. So when I have to compare these two equations, so we can easily find out what is Laplace of sin hyperbolic 2t into cos 2t is equal to 1 by 2 times, that is, so what we have to replace, the term is s by s minus 2, okay, because the term is a is 2 is here and the term is here s plus 2. So move on to the next one. So that Laplace of cos at into cos bt. Okay. Similarly, we can find out the same way. What is Laplace of sin at into sin bt? That is yourself you can do it, but I am doing here term of Laplace of cos at into cos bt. What is the formula? Laplace of that it can be shown as, that is s into s square plus a square plus b square divided by s square plus a plus b whole square, s square plus a minus b whole square. We know that what is a formula for cos at into cos bt? Can you remember the formula? That is equal to 1 by 2 times cos of a plus bt plus cos of a minus bt. So therefore, we can consider LHS side, that is Laplace of cos at cos bt. So directly we can substitute that formula, Laplace of 1 by 2 into cos a plus b into t plus cos of a minus b into t. So, by using linear property, 1 by 2 is a constant term, we can take it outside. So, therefore, 1 by 2 into Laplace of cos of a plus b into t plus Laplace of cos of a minus b into t. That is 1 by 2 into, so we know the term is cos, Laplace of cos is s divided by s square plus a plus b whole square plus, and this one, that is s divided by s square plus a minus b whole square. So, therefore, 1 by 2, the s is a common factor, can take it outside, the term is s by 2, and the remaining term we can take in the LCM, that is a here s square plus a minus b whole square, and here the terms is, the another term is s square plus a plus b whole square, that is equal to some simplification. I have to expand the term of a minus b whole square, a plus b whole square. Here minus 2ab and plus 2ab get cancelled. The remaining term is 2 times s square, 2 times a square and 2 times b square. So, therefore, it can be written as s by 2 into 2 times s square plus a square plus b square divided by the denominator, what we have to take in the LCM. So, the 2 get cancelled. So, that is equal to RHS side. Okay. Next point, that's sine hyperbolic sine AT into cos BT. So, there is the formula for sine A into cos B formula. We know that is sine A into cos B is, it is 1 by 2 into sine of A plus B plus sine of A minus B. Instead of the term is here, A is AT and B is BT. Sine AT into cos BT, that is equal to 1 by 2 times sine of A plus B into T plus sine of A minus B into T. So, therefore, you can consider Laplace of sine AT into sine, sorry, in terms of this one is cos BT, that is 1 by 2 times, we can replace the term is sine of A plus B into T plus sine of A minus B into T is 1 by 2 into Laplace of sine of A plus B into T plus Laplace of sine of A minus B into T. By using that linear property, so it can be written as 1 by 2 times, what is Laplace of sine of A plus B into T is, that is A plus B divided by A square plus A plus B whole square, and here it is A minus B divided by A square plus A minus B whole square, that is equal to 1 by 2 times, and also we can take in that LCM after simplification. So, that is a simple simplification manipulation, it can be written as 2 into A into A square plus A square minus B square, 2 get cancelled. So, that is equal to 1, the term is A into A square plus A square minus B square divided by that, what we have to take in that LCM. Next, you can find out what is Laplace of sine square AT. So, we know that by using that cos 2t formula, so we can find out that sine square AT. So, we know that cos 2AT is equal to 1 minus 2 sine square AT, which implies sine square AT is equal to 1 by 2 times 1 minus cos 2AT. So, therefore, consider that what we have to find out here, Laplace of sine square AT is equal to Laplace of 1 by 2 times 1 minus cos 2 into AT. So, by using linear property, you can 1 by 2 is a constant term, we can take it outside, and Laplace of 1 minus Laplace of cos 2AT, that is equal to 1 by 2 into, we know that Laplace of a constant term is, that is a constant divided by s, that is a constant is 1 here, is 1 by s minus what is cos 2at, the term can be written as s divided by s square plus a, the term of a is here 2a, that is 2a square. So that is 1 by 2 times, we have to take in that LCM, that is s into s square plus 4a square, that is 2a whole square is 4a square. So s square get cancelled. It can be written as 1 by 2 times 4a square divided by s into a square plus 4a square. Here again 2 and 4 get cancelled, that is 2a square divided by s into a square plus 4a square. Similarly, we can find out what is Laplace of cos square at, that is left to you. Here we are to taking Laplace of cos cube at. We know that cos 3at is equal to 4 into cos cube at minus 3 into cos at. By using this formula, we can find out what is cos cube at. That is equal to cos cube at is equal to 1 by 4 times cos 3at plus 3 cos at. Using this formula, we can find out what is Laplace of cos cube at. That is equal to Laplace of 1 by 4 cos 3at plus 3 cos at. That is equal to Laplace of 1 by 4 into, we can take it constant as, take it outside, Laplace of cos 3at plus Laplace of, that is 3 is a constant, and we can take it outside from the Laplace, 3 into Laplace of cos at, that is equal to 1 by 4 times s divided by, you know, the Laplace of cos 3at is s divided by s square plus 3a whole square plus 3 into Laplace of cos at is s divided by s square plus a square. Here also we can taking LCM and some manipulation, that is s is a common factor, we can take it outside, and the LCM is s square plus 3a square is 9a square into s square plus a square. So we can take the term as a square here plus a square plus 3 times of this term, that is 3a square plus 27a square. So, or it can be rewritten as, so we can taking some manipulation. So therefore that is a 4 into a square plus 28a square when after addition of these terms. Okay. So therefore 4 get cancelled, the terms is 4 ones are 4 and 4 7s, the terms is 28. So it can be written as s into a square plus 7a square divided by, on what we have to take in that LCM, that is a square plus 9a square into a square plus a square. Similarly, one can left the term is what is sine cube at. That's yourself, you can find out. And the last one, today's last class, last problem, and cos Laplace of cos t, cos 2t and cos 3t. Okay, and similarly we can find out, we can find out yourself, that is a Laplace of sin t, sin 2t, sin 3t. So now we'll discuss about what is Laplace of cos t, cos 2t, cos 3t. That is, we know that cos square at is equal to 1 by 2 times 1 plus cos 2 times at, and also cos at into cos bt is equal to 1 by 2 times, already know the formula, it is a cos of a plus b into t plus cos of a minus b into t. Using these two formula, we can easily evaluate the Laplace of cos at, cos 2t, cos 3t. Consider Laplace of cos t, cos 2t into cos 3t. So we can apply the formula here. Here a is equal to 1 and b is equal to 2. We have to club these two terms first. It can be written as Laplace of 1 by 2 into, that is 1 plus 2, that is 3t cos 3t, plus 1 minus 2, that is minus t, that is terms of cos of negative term is positive, that term can be written as cos t into cos 3t. Here we have to multiply the terms of cos, and also we can take 1 by 2 as a constant, take it outside from the Laplace. So 1 by 2 times Laplace of, directly we can multiply the terms of Laplace of cos square 3t plus Laplace of cos 3t into cos t. Okay. Again we can apply the terms of what is cos at into cos bt here, and also we know the formula for cos square at. Here a is equal to 3. So in these two we can apply these formulas. So the term can be written as 1 by 2 times this Laplace of cos square 3t is, here instead of a we can substitute 3. So that is 1 by 2 times 1 plus cos 2 into 3, that is 60. That is a Laplace of 1 plus cos 60 plus what is Laplace of cos 3t into cos t, that is a is equal to 3 and b is equal to 1, that is 1 by 2 times cos 4t plus cos 3t minus 1, sorry 3 minus 1, that is 2t. So therefore Laplace of 1 by 2 times cos 2t plus cos 4t. 1 by 2 is a constant term, take it outside from that, or you can take in the common factor, that is 1 by 4 times. So when I have to multiply that Laplace inside, that is by using a linear property, Laplace of 1 plus Laplace of cos 60 plus Laplace of cos 4t plus Laplace of cos 2t, that is 1 by 4 times Laplace of 1. Can rearrange the term here. First the Laplace of 2t, Laplace of cos 4t plus Laplace of cos 60, and we know that Laplace of a constant term, constant divided by s, plus Laplace of cos 2t, that is s divided by s square plus 2 square. Similarly the Laplace of cos 4t is s divided by s square plus 4 square. Last one, that is Laplace of cos 60 is s divided by s square plus 6 square. So this is the value of this one. When I have to final step is we can expand the terms. This one is 4, this one is 16, this one is 64. Okay. So you can find out yourself the problem, that is what is Laplace of cos square at and Laplace of sin cube at and Laplace of sin t, sin 2t and sin 3t. That is left to you. So this is the end of this session. Thank you.